Welcome to Algebra 2, Unit 6, Lessons 3 and 4 Practice Problems. Before we can start on this first problem, we need to look at some terminology. The first thing is a radius. If we have a circle, from the center to the circle is the radius. Now, if we want to go all the way across the circle, this would be a diameter. And if we go halfway around, this is pi. So if we were to go all the way around, all the way around is our circumference. So halfway from the center out to the circle is the radius. All the way from one side of the circle to the other, going through the center point, is the diameter. Going all the way around the circle is the circumference. And going halfway around the circle is equal to pi. Now, with these in mind, C is a circle with radius r. Which of the following is true? Select all that apply. A says the diameter of C is 2 times the radius. Well, if the radius is halfway across the circle, then 2 times the radius would be all the way across the circle. So A is correct. B, the circumference of C is pi times r. So if we want to know how long the distance is all the way around the circle, r would tell us how big the circle is. So it tells us how far from the center we are. And now we're measuring all the way around the circle. But pi is only halfway around the circle. So if I want to go all the way around the circle to get the circumference, I need to go out from the center a distance of r, and then I need to go 2 pi to go all the way around. So C would be the correct choice because B is only a half circle. And then if we look at D and E, says 1/4 of the circle has length. So first off, you go out from the center a length of radius. And then as you go 1/4, you've gone halfway to pi. So it wouldn't be pi divided by 4, it would be pi divided by 2 because pi is halfway around the circle, so half of that would be pi over 2. Pi r over 4 would actually be 1/8 of a circle. If you have any questions about how I solved this practice problem, please use class time to ask for clarification. This material is very important not only for trig, but also for any type of calculus if you're going to need that in the future. The table shows an angle measure in radians and the amount of rotation about a circle corresponding to the angle. For example, 2 pi radians corresponds to 1 full rotation. Complete the table. So, if we have an angle measure of 0, we have not rotated around the circle at all. The next angle measure is pi over 6. Well, pi is half a circle. So if we have half a circle and we've divided it into sixths, then this means we have 1/12 rotation around the full circle. Next, we have 1/8 of a rotation around the circle. So if we have gone 1/8 of the way around the circle, then to make that the angle measure of the full, we would say this was pi over 4. Next, we have a rotation of 1/6. So 1/6 times 2 is 2 over 6, which is 1/3. So my angle measurement is pi over 3. Now we're going the other way again. We have pi over 2. We're going to multiply that by 1/6. We're going to multiply that by 1/2. That equals 1/4. So our rotation is pi over 4. Our next one. Now we have 2 pi over 3. So if we multiply that by 1/2, we get 2 over 6, which equals 1/3. So we have 1/3 of a rotation. Next, we have half a rotation around the circle And we said that half a circle is pi. If we wanted to do the math the same way we have, that's 1/2 times 2, which is 2 over 2, which equals 1. So we have 1 pi. As we continue, next we have 3 pi over 2. If we multiply that by 1/2, we have 3 over 4. So we have 3/4 of a rotation around. Next, we have 7/8 of a rotation around the circle. Multiply that by 2. We have 14 over 8, which simplifies to 7/4. So we have 7 pi over 4 as the angle measure. And finally, if we have one rotation around, we said that it is 2 pi to make it all the way around. Mathematically, if we have 1 times 2, we have 2. So when we are working with these, if we're moving from the angle measure to the rotation, we can take the angle measure and multiply it by 1 over 2 pi. If we're going in reverse and we have the rotation, we can multiply it by 2 pi, and we get the angle measure. If you have any questions about how I solved this practice problem, please use class time now to ask for further clarification. Page 2. A wheel has a radius of 1 foot. After the wheel has traveled a certain distance in the counterclockwise direction, the point P has returned to its original position. How many feet could the wheel have traveled? Select all that apply. So the circumference, remember, is r, the distance out to the circle, and then it's 2 pi all the way around. So if it's gone all the way around, it couldn't be pi over 2. That would be 1/4 of a turn. It couldn't be pi. That would be 1/2 a turn. One rotation would make it 2 pi. 5 pi would be 2.5 turns. And we said that it's gone all the way around to return to its original position. And E would be 5 turns. So it could be E as well if it's rotated 5 turns before returning to its original position. Here are some points labeled on the unit circle. Number 1. What is the measure in radians of angle POR? So if we're looking at POR, we're looking at this 90-degree angle. But we want to measure it in radians. So if you remember, half of a circle is pi. And this 90-degree is half of that. So we would say 1/2 times pi is pi over 2. So for number 1, angle POR is pi over 2. Number 2, angle POQ is halfway between 0 radians and angle POR. What is the measure in radians of angle POQ? So now we had pi over 2, and now this is 1/2 of that. So our new angle POQ, this is going to be pi over 4. Number 3, label point U on the circle so that the measure of angle POU is 3/4 pi, or 3 pi over 4. So if I have 3 pi over 4, you can think of this as 3/4 times pi. So if point Q created pi over 4, because it was 1/4 of pi, and POR created pi over 2, because it was 1/2 of pi, then 3/4 times pi should be a point right over here, because then that will create 3/4 of pi. And number 4, label point V on the circle so that the measure of angle POV is 3 pi over 2. So if we have 3 pi over 2, you can think of it as 3/2 times pi. And 3/2 can be thought of as 1.5 pi. So 1 pi takes us halfway around the circle. But now we need another half of pi. So now we're down here at the bottom, and this is point V, because we now have a full pi, which is halfway, and then we have another half of pi, which takes us halfway around and puts us down here on the bottom. If you have any questions about how I solved this practice problem, please use class time now to ask for further clarification. Page 3. Mark the points on the unit circle with x coordinate 4/5. So I want to highlight this key term, unit circle. A unit circle has a radius of 1. So if we looked at this, out here we're at x equals 1. At the top we're at y equals 1. On the left we're at x equals -1. And on the bottom we're at y equals -1. So now, no matter where we are, if we pick a point and we draw a right triangle, the hypotenuse will always be 1 because it will always go out to a circle with a radius of 1. So number 1 wants us to mark the points with x coordinate 4/5. So you're just going to come out to the right and estimate about 4/5 and go up and place a point and go down and place a point. And these would be 4/5 y, and the bottom one would be 4/5 -y. Number 2. What are the y coordinates of those points, and explain how you know. If you remember, x squared plus y squared equals the radius squared. So if we use the information we know that we have an x value of 4/5, and we know we have a radius of 1. So 4/5 squared becomes 16/25, and 1 squared is 1. So now, to get y squared by itself, I'm going to subtract 16/25 from both sides. And I now have y squared. We can rewrite 1 as 25/25, and we're subtracting 16/25 from it. 25 minus 16 is 9. So that leaves 9/25. But this gives me y squared. To find y, I need to take the square root of both sides. So y equals the square root of 9/25. The square root of 9 is plus or minus 3, and the square root of 25 is plus or minus 5. So on our top point, when we're above the x-axis, our y value is positive. So now we know that this point is actually 4/5, 3/5, and this bottom point down here, we know that when we go below the x-axis, our y value is negative. So down here, our point would be at 4/5, negative 3/5. If you have any questions about how I solved this practice problem, please use class time now to ask for further clarification. Angle ABC measures pi over 3 radians, and the coordinates of C are about 0.5, 0.87. The measure of angle ABD is 2/3 pi radians. What are the approximate coordinates of D? Explain how you know. So for number 1, we said this angle ABC, this measures pi over 3 radians. But the angle ABD is now twice that, 2/3 pi radians. Well, the only thing that changes here is that as we go from C to D, our x coordinate is now negative, but our y coordinate is still positive. So all we have to do is take 0.5 and make it negative 0.5. And the y of 0.87 stays the same. Number 2, the measure of angle ABE, which would come all the way around to here. Well, this angle is now 5 times the original, or we can see that it's 1/3 pi away from being a full rotation. So when we're going from C to E, the x value is the same, but now the y value has been made negative. So if we want the coordinate for that, we go back to the positive x value, but now we make the y value negative. If you have any questions about how I solved this practice problem, please use class time now to ask for further clarification. Given angle of rotation centered at the origin that sends point P to a location whose xy coordinates satisfy the given conditions. So number 1, we want x to be greater than 0. so we need to be on the right side of the circle. And we need y to be less than 0, so we need to be on the bottom of the circle. So we want to be down here in quadrant 4. So if I need an angle, I'm going to rotate around to pi, around to 3/2 pi, and continue around until I hit 7/4 pi. Because I've got 4/4 when I go halfway and hit 1 pi, and then I've got another 3/4 until I hit halfway around quarter 4. So for number 1, we could say 7/4 pi. Number 2, we want x to be less than 0, so we need to be on the left side of the circle. And we want y to be greater than 0, so we need to be on the top half of the circle. So for this one, we're over here in quadrant 2. So I can go half of pi, and then I'm going to continue until I go 3/4 pi. And I'll put a point there. So 3/4 pi. And finally, number 3, we want y to be less than 0, so we need to be on the bottom half of the circle. And we want x to be less than 0, so we need to be on the left side of the circle. So we need to be down here in quadrant 3. For this, we're going to go around for a full pi, and then we're going to go 1 more quarter. So 1 pi would be 4/4. 1 more quarter would put us at 5/4 pi. If you have any questions about how I solved this practice problem, please use class time now to ask for further clarification. Lynn calculates 0.97 squared plus 0.26 squared and finds that it is 1.0085. Number 1. Explain why 0.97, 0.26 is not on the unit circle. So number 1, it's not on the unit circle because the radius is not exactly 1. The definition of a unit circle is that it has a radius of exactly 1. Number 2, is 0.97, 0.26 a good estimate for the coordinates of a point on the unit circle? This is a subjective question. Is it a good estimate? Well, it's only 85 thousandths away from being on the unit circle. So you would say yes, because 85 thousandths is very close to the unit circle. This is such a small difference that it wouldn't really make a noticeable difference. So this is a really good estimate. It's just not exact. If you have any questions about how I solved this practice problem, please use class time now to ask for further clarification. The x-coordinate of a point P on the unit circle is 0. If point P is the result of rotating the point 1, 0 by theta radians counterclockwise about the origin, what angle could theta represent? Select all that apply. So for this, I'm going to draw a diagram. We have our unit circle, so we're at 1, 1, -1, -1. Now, point P has an x-coordinate of 0. That means we're on the y-axis. So P could be at the top, where we have 0, 1, or P could be down here at the bottom, where we have 0, -1. And they're saying this is a result of rotating 1, 0, which would be this point on the right, rotating it counterclockwise. And they want to know what angle could theta represent. So let's take a look. Choice A is no rotation. Well, if we don't rotate, we're here where the blue point is at 1, 0, and we're not at either of the red points. So A is not correct. B is a rotation of 1/2 pi. Well, pi is a full rotation, so 1/2 pi would rotate to this top P. So this would be a possibility. Next, choice C says pi. Well, pi is a rotation of half the circle. Now I'm over here at -1, 0, and I'm not at either of the red points, so C cannot be correct. Choice D is a rotation of 3/2 pi, so we would go a full pi, and then we would continue another half pi. That puts us down here at the bottom on this red point where p is 0, -1. So D is also correct. And finally, choice E is 2 pi. Well, 2 pi is a full rotation of the circle. Right back to where we started at the original blue point. So we're not at the top or bottom red points. So E is not correct. B and D are the two correct choices for this problem. If you have any questions about how I solved this practice problem, please use class time now to ask for further clarification. Label these points on the unit circle. Number 1, Q is the image of P after an 11/6 pi rotation with center O. So 11/6 pi, so 6/6 would be a full pi, and that would still leave us with 5/6. So we would rotate a full pi and then another 5/6 of pi, and that would put us right about here in quadrant 4 at point Q. Number 2, R is the image of P after a 3/2 pi rotation with center O. Well, 3/2 pi, you could think of this as 2/2 pi being 1 pi, and then an additional half a pi rotation. So if we started, we rotate a full pi, but then we rotate another half a pi, and we're down here at the bottom for point R. Number 3, U is the image of P after a 2/3 pi rotation with center O. So 2/3 pi is less than pi. We could say we go about a third of a pi, keep going until we're at about 2/3 of a pi, and we can estimate we're somewhere right up in here for point U. This is about 2/3 of a rotation to 1 pi. And number 4, V is the image of P after a 1/3 pi rotation with center O. So we're going to estimate that we rotate about 1/3 of pi, and we could put a point right about here and label that V. If you have any questions about how I solved this practice problem, please use class time now to ask for further clarification. Angle POQ measures 1 radian. The radius of the circle is 1 unit. What is the length of arc PQ? So a radian is an arc length of the radius. So if the radius is 1 unit and the angle measures 1 radian, then the length of arc PQ equals 1 unit. Explain why the length of arc PQ is less than 1/6 of the full circle. Well, circumference is 2 pi. And while pi is a never-ending decimal, we can estimate it to be 3.14. And 2 times 3.14 is 6.28. So if I were to divide 6.28 divided by 6, this would be approximately 1.046. We said the length is only 1, so it is slightly less than 1/6. If you have any questions about anything we covered in these practice problems for lessons 3 and 4, please use class time now to ask for further clarification.